Hi everyone, welcome to Math World. This is Cambridge International AS and A-Level Further Mathematics, Paper 1, which is Further Pure Mathematics 1 for May-June 2023, and the code is 9231/11. So for your information, this paper is also same as 9231/12. Okay, so let's move on to question number 1. So for question number 1, let A be this 2 by 2 matrix with first row 3, 0, second row 1, 1. A, proved by mathematical induction that for all positive integers n, 2 times a to the power of n equals to this matrix. Okay, so since now we need to prove by mathematical induction, therefore the first step is to let Pn be 2a to the power of n equals to 2 times 3 power n and 0 for first row. Second row will be 3 power n minus 1 and 2. Okay, for all positive integers n. Okay, so now when, because it's mentioned here all positive integers means that your n will start with 1. So when n equals to 1, the left hand side is going to be 2a degree 1. Okay, and now this is your matrix A. So it will be 2 times 3, 0, 1, 1. Then from here, just times 2 to all the elements in the matrix, then it will be 6, 0, 2, 2. That is our left hand side. Now, for the right hand side, I will just refer to this matrix now and replace the n by 1. So I will get 2 times 3 power 1 and 0 for first row, then 3 to the power 1 minus 1 and 2 for the second row. Then from here, I will get 2 times 3 degree 1 is 6, 0. 3 degree 1 minus 1, it will be 2, and then 2. So from here, left hand side is equal to right hand side. Therefore, P1 is true. Okay, so now we assume n equals to k is true now. So when n equals to k is true, that means I'm getting pk, which is just replace the n here by k. So it will be 2a to the power of k equals to 2 times 3 power k, 0, 3 to the power of k minus 1, then 2 for all positive integers k. Okay, and now we need to prove that it is true for n equals to k plus 1. So when n equals to k plus 1, I will get p of k plus 1 is referring to 2a to the power of k plus 1. Okay, because when you look at the definition here, this is p of bracket k, and I'm getting 2a to the power of k. That means now k plus 1 means you have to prove the power of the a becomes k plus 1. Okay, so then what I need to do here is, we know that the matrix, right, a to the power of k plus 1 is same as 2a to the power of k times 2a to the power of 1. And then I will replace this 2a to the power of k with this matrix, right? So then I will get 2 times 3 to the power of k, then 0, 3 to the power of k minus 1, 2, multiply with the a. So our a is 3011. It is given in the question. So now 3011. So this becomes the multiplication of two matrices. What we do here is row 1 times column 1. So the first elements, 2 times 3 power k multiply with 3, then plus with next elements, the multiplication of next two elements. So here I will get 2 times 3 to the power of k, then times another 3, plus 0 times 1 is 0. Okay, I will just do it step by step. So plus 0 times 1. And then the next is first row multiply with second column. Okay, so it's the same concept here. It will be 2 times 3 power k multiplied by with 0, and then plus with 0 times 1. Okay, now we refer to the second row multiply with first column. So it will be the same concept. 3 power k minus 1. But then this one, be careful. These two terms multiply with 3. Okay, then plus these two multiply with 1. That is a multiplication. And then now the last one will be second row multiply with second column. Okay, so I will get 3 to the power of k minus 1 multiply with 0 plus 2 multiply with 1. Okay, so from here, when I simplify, the first one, we have a formula here. A to the power of m multiply with a to the power of n, it will be a m plus n. I refer to this formula to simplify the products of these two terms because they are same base. But just for information, even though the power of 3 is not given, basically it is 1. Okay, so by using this formula, I will get 2 times 3 to the power of k plus 1. And then plus 0 times 1 is just 0. No need to write. Then for the same row next term, here will be 0. And plus with 0, you'll be getting 0 as well. So I'll get 0. And then now, the second row, first column, this 3 multiply in, this 3 multiply to minus 1 as well. So again, this is 3 power 1. So 3 power 1 times 3 power k. I will get 3 to the power of k plus 1. Then minus 3. Because the 3 multiply with minus 1. Excuse me. Then don't forget there is a plus 2 here. Alright. Now, the last one is going to be, here is 0. Then this is 2. Okay, then now I need to further simplify. This is same as 2 times 3 to the power of k plus 1. Then 0. This minus 3 plus 2, it is minus 1. So I'm getting 3 to the power of k plus 1 minus 1 and 2. So when you compare with the AK, okay, sorry, this is your 2AK. Okay, this is your 2AK. So you should get this. Which means now, if I change my k to k plus 1, which means this k must change to k plus 1, which is here. Okay, and this k must change to k plus 1 as well. Then the rest remain. Means that I have obtained the same form. Okay, a similar form, I should say, similar form as 2 times a to the power of k. When the k replaced by k plus 1. Okay, so with this, I can just make the conclusion. P of k plus 1 is true. Okay, so by induction, Pn is true for all positive integers n. Alright, so we have done this question. Now, part B, find in terms of n the inverse of a to the power of n. Alright, so now I will rewrite my a to the power of n. It will be, look at here, you are given 2a to the power of n. Alright, so this, if you need to get a to the power of n, before you get the inverse, you must get this matrix first. This 2 will be moved down, becomes half. Alright, so I will write it is half of the given matrix. So the matrix is 2 times 3 power n, 0, 3 power n minus 1 and 2. So from here, I will simplify. Okay, I bring in the half. So when you bring in the half, this half multiply with first term, the half and 2 will be cancelled off. Then you will get 3 power n. Then half times 0, okay, you bring in half times 0. After that, the half multiply with this and multiply. So when half times 0, I will get 0. Then the second row, first column, it will be 3 power n minus 1 divided by 2. Then the half times 2, it will be 1. This is my an. So now, to get the A inverse, I need to get the determinant first. So the determinant of a to the power of n, it will be the cross multiplication, right? The green arrow minus the orange arrow. So obviously it is 3 power n times 1 minus 0. Then I will get 3 power n. Okay, so then the a n inverse, it will be 1 over determinant, right, times adjoint an, right? Adjoint an means, look at the an, you swap these two values, okay, interchange these two values, means that I will get 2, then 2 times 3 power n, and then for the other two values, these two values, you times minus, okay, times by minus. So I will get 0, negative of, I will refer back to this, okay? You times minus to this value, times minus, right? So negative of 3 power n minus 1 over 2. And then means that here I need to change. I shouldn't refer to the original. I should interchange these two, right? So I will get 1 and then 3 power n. Okay, then now for final answer, you can just simplify. 1 over 3 power n, it will be 3 power negative n. And then 1, 0 for first row. Then for the second row, the over 2 can be factorized out. And then the minus you can bring in. Okay, so I will get half of 1 minus 3 power n. And then the other one is 3 power n. This is our A inverse. The AN inverse. Alright. So then now we move on to question number 2. Okay, for question number 2, the cubic equation, this is a cubic equation, has roots alpha, beta, gamma. A, find the value of sum of the squares of each root. Okay, so firstly, I will write down the given cubic equation. Okay, has roots means alpha, beta, gamma. Okay, has roots x equals to alpha, beta, gamma. Because your equation in terms of x, that's why the roots means the x values. So from here, I will list down the coefficient for each of the terms. So the coefficient of x cubed will be 1, which is a. B is the coefficient for x squared, which is 4. C is coefficient for x, which is 6. Then D is a constant, which is 1. Okay, so from here, I let summation of the roots, means that summation alpha equals to minus b over a. Then I will be getting minus 4. Then summation alpha beta means products of any two roots. It will be c over a. Then I will get 6. Then after that, alpha beta gamma, it is minus d over a. Then I will get minus 1. Okay, so now alpha cubed plus alpha squared. We need to solve alpha squared plus beta squared plus gamma squared. This is same as summation alpha squared. So summation alpha squared is square of summation alpha minus 2 summation alpha beta. So now summation alpha, it will be minus 4. So minus 4 squared minus 2 times summation alpha beta is 6. Therefore 16 minus 12, it will be 4. So that's the A solution. Okay, now B, use standard results from the list of formula, which is MF19, to show this sum equals to n bracket n squared plus an plus b, where a and b are constants to be determined. So now I will copy the summation first. Summation alpha plus r squared plus beta plus r squared plus square of the alpha gamma plus r. Then the r start from 1 until n. So from here, I will do the expansion. So when you square the alpha plus r, so I'm going to use a plus b squared, which is a squared plus 2ab plus b squared. Right? So now you will be getting alpha squared plus 2 alpha r plus r squared for the first bracket. And then the second expansion, it will be beta squared plus 2 beta r plus r squared. And then the last expansion will be gamma squared plus 2 gamma r plus r squared. Okay, so from here, right, I can group the terms with r or r squared or without the r. So firstly, I will have r squared plus beta squared plus gamma squared. All these are without the r. So it will be summation r from 1 to n, then alpha squared plus beta squared plus gamma squared. That is my first summation. Then after that, I will refer to those with the r, which is the red color, which is underlined by red color. Okay, so from here, I notice that the 2r will be in common. So I will factorize 2r. So then 2r bracket alpha plus beta plus gamma. Then lastly will be the remaining terms, all the squares. Right? So from here, this is r squared, r squared, r squared, which means when you plus together, it will be 3r squared. Okay, so now from here, summation. So I can split it into 3 summations. So the first one is going to be summation alpha squared plus beta squared plus gamma squared. And then plus 2 alpha, beta, gamma. I will factorize the summation of these 3 terms because your sigma here, okay, because your sigma here is regarding the r. Therefore, the r should be the it should be inside the summation. So here will be r, then plus factorize the 3 summation r squared, r from 1 to n. Okay, so now from here, okay, the meaning of this term is, we know that r squared, alpha squared plus beta squared plus gamma squared, we have solved it just now, which is 4. So this is a constant, means that you add this constant for n times, because r from 1 to n is actually n times. So now I will be getting the sum as minus 4, which is from the previous calculation, positive 4, sorry. Positive 4, which is from the previous calculation. Then the sum, that means you are getting 4n. Okay, and then here is going to be plus 2 bracket. This alpha plus beta plus gamma is our summation alpha here, which is minus 4. So, which means I will replace it by minus 4. And then for your information, this summation r, right, this summation r from the formula list, you will get half n plus 1. This is the summation r. Right? And then for the next one, it will be plus 3. Summation r squared, again from the formula list, you will get 1 over 6 n bracket n plus 1 multiplied with 2n plus 1. Alright, so with this now, we just need to simplify it to get this form. So from the final answer, we need to factorize the n. Right, so now I will simplify 4n. Then the next one is half and 2 cancel off. Then this minus 4, you times into the n, becomes minus 4n. Then multiply with the n plus 1. Then you will be getting minus 4n, then minus 4n squared. Okay, look at here. This minus 4n, you multiply with the n, it will be minus 4n squared. So I should write 4n squared first. Then after that, minus 4 times n is minus 4n. Then multiply with 1, you will get minus 4n. Right, hang on please. Okay, then the next one is I will simplify the 3 and 1 over 6. These two, when you simplify, it will be half. Alright, so I will get half n. So half n. Then this part I will do expansion. So when I do expansion, I will get 2n squared plus n plus 2n plus 1. Okay, then from here, since I have half here, that means I will factorize a half from all the terms. And then I notice that I have n here, n and n. Basically, this first and third term will be cancelled off. Means that you only have this term, right? Negative 4n squared. So again, the n is in common. Alright, so from here, I will factorize n. So once I have factorized half n from the negative 4n squared, I will get minus 8n. Then plus all these terms. So when I simplify the second and third term, I will be getting 2n squared plus 3n plus 1. Okay, the next step is rewrite the half n. Then I will get 2n squared. Now, this minus 8n plus 3n, it will be minus 5n. So I will get minus 5n plus 1. And this quadratic can be simplified. Okay, wait. Let's see the answer here. No need to simplify, okay? But we need to get 1n over here. Means that now, I have to times in the half. Okay, I have to keep my n outside. This half will be times into the bracket. So when I times into bracket, I will get half times 2 is 1. Then it will be n squared minus 5 over 2n plus 1 over 2. So means that now my A is minus 5 over 2 and B will be positive half when I compare to this general form. Right? So now let's move on to question number 3. A. Use the method of differences to find this summation in terms of n and k, where k is a positive constant. So before we apply method of differences, basically method of differences means that you need to get the summation of two functions, fr minus 1. Then this will be, right, once you get this, then it will be fn minus f0 because your r is 1. Okay, then now in order to get the subtraction of two functions, the fr minus 1, I need to find the partial fractions of this rational function. So 1 over kr plus 1 multiply with kr minus k plus 1. By looking at these two factors, right, you must remember that the k is a constant, means that the variable is the r. So by looking at the degrees of the r, both are 1. Means that now you are given two linear factors. Then I should write kr plus 1 and the other factor will be kr minus k plus 1. So both numerators will be constants a and b because you are given linear factors. So then after that, we need to compare to the left hand side to get the same denominator. So since you have the first factor, I just need to multiply with another factor, the second factor. And same for the b. So I will rewrite the b term and then multiply with. So now you are given the second term, means that you need to multiply with the first factor, which is kr plus 1, then over kr plus 1. After that, for the left hand side, I will just rewrite the rational function. Okay, so by looking at this, you will notice that the denominators are the same, which means I can just cancel off the denominators and write down the numerators. So 1 equals to a times kr minus k plus 1 plus b times kr plus 1. So remember, I need to get the r value in order to get a and b. Normally, this can be found by using or by letting the factor be 0. That's why this is what I'm doing now. Then I need to get the R value. So KR equals to K minus 1. Therefore, the R is going to be, or basically, I do not need to find the R as well, because when I let this be 0, I just need the value of KR plus 1. So it will be KR plus 1 equals to, when I keep this together, this minus K move to the other side. So I will get K. So now I will write 1 equals to the A times 0 plus B of K. Okay, then BK is 1, which means my B is 1 over K. Right? So now the next is I let KR plus 1 be 0. Then now, okay, I need to get the K value, the R value. So which means my R is basically minus 1 over K. So now I'm substituting this value into this equation. So 1 equals to A bracket, I need KR. Okay, so basically from the previous step, I can just find KR instead of just R. So I keep the KR. So KR equals to minus 1, which means here is going to be minus 1. So minus 1 minus K plus 1. Then plus B bracket 0. So minus 1 plus 1, it will be 0. That means I will get 1 equals to A bracket minus K, which means my A is basically negative 1 over K. Okay, so once we have found the constants, just replace the values in the partial fractions. So I will rewrite the rational function. Then it will be negative. Now please do not write negative 1 over K then over the KR plus 1. So we will just factorize the negative 1 over K. So I will write negative 1 over K bracket 1 over KR plus 1. Now my B is 1 over K. So again, since your B is a rational function, or it is a fraction, I would say it is a fraction, factorize a 1 over K as well. So now I will get plus 1 over K bracket 1 over KR minus K plus 1. Okay, so the next step is consider the sum. Sum from R, sum R equals to 1 until n, then the whole rational function. So from here, I will notice that the 1 over K is in common. So I will factorize 1 over K, or I will factorize negative 1 over K. Then I will consider the summation R from 1 to n. It will be 1 over KR plus 1 minus, okay, because I factorize a minus. So the second term, in order to get plus, it will be minus. Then 1 over. Now, just now I have explained the method of differences means that the first is FR, the second is FR minus 1. So now from here, for the KR minus K plus 1, I will change it to K bracket R minus 1 plus 1. So then I will let my FR be 1 over KR plus 1. Hence, my F of R minus 1, it will be 1 over. When you look at the function here, when here is R, this is R. So when R minus 1 means that this R will be replaced by R minus 1. Then I will be getting K bracket R minus 1 plus 1. That means it's exactly the same as the second rational function in the previous step. So then I will write, it will be 1 negative 1 over K summation R from 1 to n. This first term is my FR. Second term is my FR minus 1. Okay, after this, just substitute the n into the first R and then substitute the R into the second R minus 1, the second term, which means I will be getting negative 1 over K bracket Fn minus F0. Okay, So now I will replace my fr here, the r here, by n, because we need to get fn in the working. So which means now I will get negative 1 over k. So fn, it becomes 1 over kn plus 1. Alright, based on here. This one change to n. This one will change to n. Then minus f0. Now you let the r be 0. Alright, so here becomes minus 1 over k bracket 0 plus 1. Then you will get negative 1 over k, 1 over kn plus 1 minus k times 0 plus 1 is basically 1. So since there is a negative outside the bracket, then I can just times in the negative and rearrange it. So it will be 1 over k. So the minus times minus 1 is positive 1. So I will write the positive 1 first, then minus 1 over kn plus 1. Okay, so this is our sum. This is our summation. Okay, now B, deduce the value of the same summation, but then instead of n for the last r value, now it becomes infinity. So for your information, this summation r from 1 to infinity, it is the limit. Okay, we can consider the limit when the n tends to infinity. So this is limit n tends to infinity, summation r from 1 to n. Alright, then now I will copy this result from the previous part, which means is this. Okay, so I will replace it. Then here becomes limit n tends to infinity, 1 over k bracket 1 minus 1 over kn plus 1. So remember, your n tends to infinity, when your n tends to infinity, 1 over kn plus 1 will tend to 0. Therefore, the summation 1 over kr plus 1, kr minus k plus 1, the n tends to 1 from the r from 1 until infinity, it will tend to 1 over k times 1, which means tends to 1 over k. Okay, now C, find also this sum. But then now your sum, the r from n until n squared. Alright, so now we need to consider the sum from 1 until n squared. So this is sum from 1 until n. Okay, now you see, we need to count the sum start from n until n squared. That means I will use the total sum. Okay, so it means that from 1 to n squared for the whole rational function, then minus the previous sum. So the previous sum will be r from 1 until n minus 1. Right, so remember just now we get this result when it is the sum until n. So when you need to get the sum until n squared, which means I will replace this n by n squared. So the rest remain. So which means now it will be 1 over k bracket 1 minus 1 over k of n squared plus 1. That is the first sum minus the second sum 1 over k times by 1 minus. Replace the n by n minus 1 because the highest r is n minus 1 right now. So I will get 1 over k bracket n minus 1 plus 1. Okay, then now I can factorize the 1 over k and open the brackets. So it will be 1 minus 1 over kn squared plus 1 minus, so this minus will be brought into the bracket. So it means that the first term you will get minus 1, second term is plus 1 over kn, here we do expansion, minus k plus 1. Okay, or if you want to do expansion, we can just leave it. That will be better. So I will write k of n minus 1 plus 1. So now, from this step, you will notice that first and third term will be 0. Okay, then I just need to rearrange. This be the first term inside the bracket, and this is second term inside the bracket. So final answer 1 over k bracket 1 divided by k of n minus 1 plus 1, then minus 1 over kn squared plus 1. That is our solution for this question. Okay, now question number 4. The matrix M is given by this matrix, 2 by 2 matrix, where A, B, C are real constants and B is not equal to 0. A, show that M does not represent a rotation about origin. Okay, so just for your information, if it is rotation about origin, okay, it is anti-clockwise, let's say, anti-clockwise, right, and the angle is theta, then we will be getting this form. Cos theta, negative sine theta for the first row, sine theta, cos theta for the second row. Okay, but if it is clockwise rotation about the origin as well, then you will be getting, this is minus, here is positive. Okay, the rest remain. Then now you will need to show that M does not represent a rotation about the origin. So I will just simply take one of this form. So now if I need to let it be rotation first, then from there I will prove it is not, which is by contradiction. So A, B squared, C squared A, this is a given M, equals to cos theta, negative sine theta, then sine theta, cos theta. Okay, so from here, when you equate them, you see the A, cos theta. But then now, I need to compare the squares. B squared is negative sine theta. Okay, then I will write down here. B squared equals to negative sine theta. And then the C squared is going to be sine theta. We'll compare. So from here, I will say that my B squared is negative of C squared because the sine theta will be replaced by C squared. Okay, and now you look at the definition here. A, B, C are real constants. So since A, B, C are real constants, means real numbers, and then the B is not 0. Alright, so B squared equals to minus C squared is true when the B equals to 0. But since the B is not 0, that means B squared minus equals to minus C squared is impossible. Right, is impossible. So when it is impossible, which means the M does not represent a rotation about the origin. Alright, so that is how we solve the question 4a. Now B, find the equations of invariant lines through the origin of the transformation in the xy plane represented by M. So first of all, I will write xy equals to M of small x, small y. So now my M is basically A, B square, C square, and A multiplied with xy. So when you look at this, the first matrix is 2 by 2, the dimension. The second matrix is 2 by 1. So it means that I will be getting 2 by 1 matrix after the multiplication. 2 by 1 matrix means that you have 2 rows and 1 column. So how to get it? Row times column. That means I will be getting ax plus b squared y. That's the first row, first column. And then my second row, first column is going to be c squared x plus ay. Okay, since it is a invariance through origin, which means y equals to mx, right? This is going to be my x and y. So now I will equate them. That means c squared x plus ay, which is my y coordinate, the y component, and then it will be m of ax plus b squared y. And at the same time, my y in this equation will be replaced by mx. Because now you need to find the equation. Actually, this y equals to mx is the equations that you need to find. It's just that we need to find the m now. So now I will get c squared x plus a bracket mx equals to m times ax plus b squared bracket mx. Okay, so from here, we can cancel off all the x because you see all the x on both sides. So when I cancel the x, I will get, means that I divide by x, then I will get c squared plus am equals to this m times in, it will be am, plus this m times in, it will be b squared m. b squared m squared, okay? The m and m can times together. So when you look at here, the am can be cancelled from both sides. Then now I need to get the m values. So c squared is b squared m squared. Right? So now from here, I will say that my b squared m squared minus c squared equals to 0. Then now, to get the m, I will use this formula, difference of two squares. So a squared minus b squared will be a minus b times a plus b. Alright, so this is my a. This is my b. So my a is bm. My b is the c in this formula. So then I will get bm minus c times bm plus c equals to 0. So the first one, bm minus c equals to 0, means that the m is c over b. The second one, bm plus c equals to 0, means that the m is negative c over b. So found two m values, therefore we get two equations. Equations of invariant lines through origin. Y equals to mx. So the first m is c over b, then times x. The second will be negative c over b times x. So these are the two equations. Okay, now it's given that m represents the sequence of two transformations in the xy plane given by enlargement, center the origin, scale factor 5. Okay, this is this is one of the transformations. Then the second is, okay, sequence. That means this is the first transformation. Then followed by a shear, x-axis fixed and with 0, 1 map to 5, 1. This is a second transformation, 5m. So for your information, right, for the enlargement, if let's say it is enlargement with scale factor k and the center origin, then the matrix is going to be K0, 0, K. Okay, so now from here I know that for the enlargement, the matrix is going to be, because the scale factor is 5, so I will get 5, 0, 0, 5. That is the enlargement matrix. Now for the shear, okay, so now I will just write it here. So for the shear parallel to x-axis, right, basically x, y, the coordinates of the point, will be converted to x plus ky and then y. So in this case, the matrix, it will be 1, k, 0, 1. Okay, so now our question here mentions 0, 1 map to 5, 1. So now this is a shear 0, 1 map to 5, 1. So the y remains. Then I will just use this formula, right, which means 5 equals to 0 plus k times 1. Okay, look at here, right? So x plus ky. So x is 0. 0 plus ky, y is 1, equals to the new x coordinate, which means now my k is going to be 5. Then I have found the k in the matrix here. So it means that for the shear matrix, right, it's going to be 1, 5, 0, 1. Now my m, since the first transformation is 5, 0, 0, 5 is an enlargement, so we will write it at the back. Okay, then the front matrix is going to be the second transformation. Then now I will just do expansion to get the m squared, to get the m. So when I do the expansion, it will be row 1 times column 1. So 1 times 5 is 5, plus 5 times 0 is 0. Okay, let's say I do it step by step. Then first row times second column. So I will get 1 times 0 plus 5 times 5. After that, instead of first row, now we refer to second row, sorry. We refer to second row. That means you will get, this is 0, 5. Okay, so second row times first column. So it will be 0 times 5 plus 1 times 0. Then second row times second column, it will be 0 times 0 plus 1 times 5. Okay, so at last you will get 5 and then 5 squared. You can write 5 squared or 25, it's up to you. Then the second row first value is going to be 0. Second row second value is going to be 5. That is our m. Okay, now D. The triangle DEF in the XY plane is transformed by M onto the triangle PQR. Given that the area of triangle DEF is 12 centimeters squared, and the area of find the area of triangle PQR. So the area of triangle is after the transformation. The triangle PQR is after the transformation of DEF. So then area of the triangle PQR, it will be determinant of the M times area, okay, times area of the triangle DEF. Right? So now this is our M. To get the determinant of M, it will be determinant of the whole matrix. So we have solved the determinant in previous question. It is the cross multiplication. Means that you have to use the red arrow minus the green arrow. So I will get 5 times 5 is 25 minus 0, therefore is 25. Then I will get here 25 times area of the triangle DEF is 12. Therefore, you will get 300 centimeters squared. Alright. Now, the next question is number 5. The curve C has polar equation r squared equals to 1 over theta squared plus 1 for theta defined from 0 to pi, inclusive. A. Sketch C and state, this is the first, this is the second. State the polar coordinates of the C furthest from the pole. Okay, so now for this, I need to get the r value corresponds to the theta values. So theta, and here is going to be the r, because we do know the shape of this. So when theta equals to 0, I get 1. Theta equals to pi over 6, it will be 0 0.785. Pi over 4, 0 0.618 for the r. Then pi over 3, you can find more theta. Okay, then it will be 0 0.477. Then now the next is pi over 2, you get 0 0.288. After that, 2 over 3 pi, you will get r equals to 0 0.186. For 3 over 4 pi, it will be 0 0.153. 5 over 6 pi, then 0 0.127. At last, I get pi. The r is 0 0.0920. Okay, so with all of this, then we can just draw the sketch a curve C. So this is theta equals to 0. Let's say, now please measure using the protractor. Here I just simply draw the angle, okay? So it is not accurate. So here, let's say this is pi over 4. Then this is going to be three over 4 pi. Okay, then pi over 6. Then this is pi over 3. This is pi over 2. So I use dotted line to label the angle. So for you, please use the protractor, okay? So here is going to be 2 over 3 pi, then 5 over 6 pi. This is pi. Alright, so your r is 1, then you can just use a scale 1 centimeter, or you just enlarge it. You times 3 or times 4. Okay, so then you can mark it easily. So then let's say here is the first value. I times 4 for all these r values. Then after that, it will be here. Basically, it is decreasing. See, from 1 decrease until the pi. So then I will join all the points. Okay, so please draw according to the scale. Here I will just roughly show you the shape. Okay, basically you should get this shape. Right? So if you sketch according to the scale, then you will get the accurate graph. Here I will just simply sketch. Right, so this is my r equals to 1 over theta square plus 1. That is my curve C. Sorry, r squared. Okay, r squared. And then now, we need to get the polar coordinates of the point C furthest from the pole. This is the pole. Okay, furthest from the pole obviously is the first one. Right, because the r is the longest. So now, the point or coordinate, polar coordinates of the point of C furthest from the pole equals to r theta. So the r is 1 when the theta is 0. Right? Now B, find the area of the region enclosed by C, the initial line and the half line, theta equals to pi. So now, the area of the region is basically half r squared theta. The theta from 0 because it's initial line until pi. So then here half integrate 0 to pi. The r squared is given 1 over theta squared plus 1. So to solve this integration, we need to refer to the inverse tangent formula, which is 1 over a squared plus x squared. You integrate this function, it will be 1 over a inverse tangent x over a plus c. So be careful with this, the a must be a constant. Alright, so now you see here dx, this is x squared. Here's d theta, that means our x has been changed to theta, which means your a is a 1, okay, because 1 is same as 1 squared. So I can direct apply the formula, it will be 1 over 1, which is 1. So then it will be inverse tangent theta over 1. According to this inverse tangent formula. So I will rewrite, it will be half inverse tangent theta. Then I'll replace the theta by pi first. I will get half inverse tangent pi minus inverse tangent 0. So inverse tangent 0 is basically 0. Then when you calculate this using radians mode in your calculator, you will be getting 0.631. So this is the area of the region bounded by the curve and also the two lines. C. Show that at the point of C furthest from the initial line. Okay, it's no longer furthest from the pole, it's furthest from the initial line. This is the equation. And verify that this equation has a root between 1.1 and 1.2. Okay, so what does it mean by this furthest from the initial line? Let's look at the curve. We know that this is initial line. Okay, so when furthest means it will be the vertical distance. So vertical distance, which is y value. Okay, so then now instead of using r, I have to use the y now. So we know that from polar coordinates, the y is r sine theta. And then you are given r squared is 1 over theta squared plus 1, which means your r is basically square root of 1 over theta squared plus 1. Okay, so instead of writing this, I will write 1 over square root of theta squared plus 1. It will be the same. So then now, my y equals to sine theta times the r times 1 over this, which means it's over square root theta squared plus 1. Okay, so if I do it step by step, I will write here 1, then here sine theta, then sine theta over square root. Now, this is my furthest. Okay, my point my coordinate of the point C furthest from the initial line. But then when you see, the furthest here means the maximum vertical distance. So to get maximum y value, we need to differentiate the y with respect to theta. So now your y is a division of two terms. When you need to differentiate division of two terms, we need to refer to quotient rule. Alright, so according to quotient rule, d over dx u over v, it will be v squared v u prime minus u v prime. So now I can write down my uv first. My u is a sign. So let's say I write here. My du over d theta, which is my u prime. Okay, I will write u prime. Differentiate sine theta, it will be cos theta. Then v is square root of theta square plus 1. This is same as degree half of theta square plus 1. So my v prime, I will bring down the half. Then it will be theta square plus 1. The half u minus 1 becomes negative half. Then differentiate theta square plus 1 is going to be 2 theta. Now, this can be simplified. The 2 and half cancel off. Okay, and now you are getting negative degree over here, means that I can bring it down, which means my v prime is theta over square root theta square plus 1. So now substitute the terms inside into this formula. I will get over v squared. So I square this v. Then vu prime. I will write this square root first. This is my v. U prime is a cos theta. Minus uv prime. U is sine theta. The v prime is theta over the square root. Now, from here, I see the square root from the second term, and this square root is in the denominator, means that I can factorize it from the numerators here, okay, these numerators. So I factorize the square root. Once I factorize the square root, 1 over square root. Okay, the first term here, look at here, this first term is positive degree half. Right, I factorize the negative degree half, means that you still have degree 1 for theta square plus 1 cos theta. Then minus, once you have factorized the denominator, you still have theta together with the sine theta. So I will get sine theta over the 2 and degree half, or on the squared and the square root can be cancelled off. So theta squared plus 1. Okay, at last, this square root can be brought down. So the square root is actually degree half. Degree half together with this degree 1, it becomes degree 3 over 2. So I will get theta squared plus 1 times cos theta minus theta sine theta over theta squared plus 1 to the power of 3 over 2. Now, because of furthest means maximum distance, right? Maximum vertical distance means that dy d theta is 0. So when dy d theta equals to 0 means that my numerator equals to 0. Okay, and now look at the question here. You need to prove cotangent theta. So we know that cotangent theta is cos theta over sine theta. So which means I need to, because of the cos theta here, in order to get cotangent theta, I need to divide the whole equation by sine theta. So I will get theta squared plus 1 cos theta over sine theta minus theta sine theta over sine theta equals to 0 over sine theta is still 0. That means I'm getting theta squared plus 1 cot theta minus theta equals to 0. Let's look at the question first. Okay, I need minus 1, already found the minus, oh, not yet. So it means that in order to get the minus 1 here, right, from this minus theta, which means I need to divide the whole equation by theta. So I will get theta squared plus 1 divided by theta cot theta minus theta over theta equals to 0. So which means now, when you look at the question, we need to get theta plus 1 over theta times cot theta. So it means that now I need to split it into two terms. Theta squared over theta plus 1 over theta cot theta minus 1 equals to 0. So theta squared over theta is theta, right? So in order to get the same form as in the question, the first one must be theta. So here, theta plus 1 over theta times cot tangent theta minus 1 equals to 0. Alright, so with this, we have shown the form, or shown the equation. Okay, now, and last part, verify this equation has a root between 1.1 and 1.2. So to verify this, we need to apply the sign change rule. Means that firstly, I will define this whole equation as the f theta. So f theta equals to theta plus 1 over theta multiplied with cot theta minus 1. So you need to prove that it is between 1.1 and 1.2. So now you count f 1.1. So it will be 1 plus 1 over 1.1 cot tangent 1.1 minus 1. So when you need to count the cotangent 1.1, make sure this is the radian, the calculator is in radians mode. Okay, this is in radians mode. Then you will get 0.0226, which is greater than 0. And then f of 1.2 is going to be 1.2 plus 1 over 1.2 cotangent 1.2 minus 1. Then this is going to be negative 0.209 and is less than 0. So from here I will write, since f 1.1 is greater than 0 and f 1.2 is less than 0, there is a sign change. Hence, there is a root. Okay, the equation has a root between 1.1 and 1.2. So this is a sign change rule. Okay, now question 6. A curve C has equation y equals to x squared plus 2x minus 15 divided by x minus 2. Find the equations of the asymptotes of C. Now, to find the asymptotes, we have vertical plus horizontal, or vertical plus oblique. Okay, so when you look at the degree of x in the numerator, the highest is 2. But then the degree of the highest degree of the denominator is only 1, which means the oblique asymptote exists. So oblique asymptote can be found using the polynomial division. So now I divide first. X squared plus 2x minus 15 divided by x minus 2. In order to get x squared here, from x I need to multiply with x squared. Sorry, I need to multiply with x. So the x multiplied with x minus 2, it will be x squared minus 2x. Oh, minus So x squared minus x squared is 0. 2x minus minus 2x becomes 4x, then minus 15. Right? Then now, to get 4x from x, I need to multiply with plus 4. So it will be 4x minus 8. And then I minus 15 plus 8, it will be minus 7. So from here, I will get my oblique asymptote. So my oblique asymptote is basically the quotient, which is x plus 4. Y equals to x plus 4. Then the vertical asymptote is when the denominator equals to 0. So when my x minus 2 equals to 0, which means the x equals to 2. Okay, just let this be 0. Alright, so we have solved 6a. Now B, show that C has no stationary points. Whenever you see stationary points, means that dy dx equals to 0. When it is no, means that you won't get any x when you solve dy dx equals to 0. So for information, this dy dx can be found using by differentiating the original y, or you can change to the by referring to the polynomial division, which means you write in quotient plus remainder over divisor. So you have two options here. Right? I will use back the original y. So my y equals to x squared plus 2x minus 15 divided by x minus 2. Again, this is the quotient rule. d over dx, u over v, it will be v u prime minus u v prime over v squared. So now from here, I will write down my u is x squared plus 2x minus 15. My u prime is 2x plus 2. Then my v is x minus 2. V prime is 1. Okay, so then dy dx, it will be v squared. So x minus 2 squared. Then vu prime, based on the formula, it will be x minus 2, 2x plus 2, minus uv prime. So the quadratic, the v prime is 1. So from here, I will do expansion for the numerator. When you expand, x times 2x, 2x squared, x times 2 plus 2x, minus 2 times 2x, it will be minus 4x, minus 2 times positive 2, it will be negative 4. Then this minus will be bring in to the whole bracket because you multiply with 1. So it means that all the terms, first two terms will be negative, and then the last term becomes positive. Okay, so now I simplify the numerators. 2x squared minus x squared, it will be 3x squared. Then 2x minus 2x is 0. Then I have another minus 4x, which means the answer is minus 4x. Lastly will be the constants. So minus 4 plus 15, it will be plus 11. Okay, now when I look back the working, it is positive 1x squared because 2x squared minus 1x squared is 1x squared. Alright, this is my dy dx. And now, to get the stationary points, I let this be 0 first. And I have to show that when dy dx equals to 0, there's no x, no solution. So x squared minus 4x plus 11 will be 0. Then, to show that there's no solution for this equation, for this quadratic equation, I can just use the discriminant. So the coefficient for x squared is a equals to 1. Coefficient for x, b equals to minus 4. And then the constant, I let it be c, equals to 11. Discriminant is b squared minus 4ac, which is square of minus 4 bracket, a is 1, C is 11. Then you will get 16 minus 44, which is negative 28, and is less than 0. So from here, we just write since b squared minus 4ac less than 0, right? Means no root when dy dx equals to 0. Or on the other words, okay, no stationary point. Alright, so that's the solution for B. Now sketch a curve stating the coordinates of the intersections with the axis. So now I will rewrite my curve function. Y is x squared plus 2x minus 15 over x minus 2. So now we have oblique asymptote y equals to x plus 4 and x equals to 2. So now when intersection with the axis means when x equals to 0, my y is going to be 0 plus 0 minus 15 over 0 minus 2. Just replace the x by 0 here. Then I will get minus 15 over minus 2, which is 15 over 2. And then when my y equals to 0, so x squared plus 2x minus 15 over x minus 2 equals to 0, which means now x squared plus 2x minus 15 equals to 0. Then from here, I will simplify it into x minus 3, x plus 5 equals to 0. Hence, the x equals to 3 and minus 5. Okay, so I get 3 points here. So it means that points equals to 0, 15 over 2, and then 3, 0, and minus 5, 0. Now with all this, I need to sketch a graph. And remember that there's no stationary points. Alright, so then I sketch. My y needs to be considered up to 15 over 2. 15 over 2 is 7.5. So my scale will be 2 units for 1 centimeter. So 2, 4, 6, 8. Maybe this is 10. And then here is going to be the same scale. Now, firstly, x equals to 2 is my asymptote. So please draw this using ruler. Draw the straight line, the dotted line, to represent the asymptote. Then y equals to x plus 4. So when y equals to x plus 4, when x equals to 0, your y is 4. When y equals to 0, the x is minus 4. Okay, I get 2 points. So it means that it will be 0, 4. So 0, 4. And then negative 4, 0. Again, join these 2 points using ruler. So this is y equals to x plus 4. It's my asymptote. And then I know that it will be intersecting at these 3 points. So 3, 0, minus 5, 0, and then 0, 15 over 2. So 0, 7.5. Let's say here is 7.5. So since there's no intersection point, there's no stationary points, means that it will be this graph. Okay, maybe I draw it here first. Okay, so you need to draw a smooth curve. Right? So this will be my curve C. Okay? So make sure when it tends to infinity, when it tends to positive 2, the x equals to positive 2, it will not touch the dotted line to show that it is asymptote. Alright, so this is going to be my C. Okay, so I will label this as y equals to x squared plus 2x minus 15 over x minus 2. So the curve is done. Then you need to state the coordinates. So I will just state here. Of the intersections with the axis equals to all these 3 points. Right? So now D, sketch the curve with equation. So then you check the next question is going to be plus, plus, minus. Okay, so here supposed to be plus. Alright, so that it will be the same as the previous function. So what we need to do is we redraw this graph, but all the negative parts, which means here, will be reflected in the x-axis because of the modulus. So I need to redraw the graph or resketch the graph. Now remember just now we have the asymptotes. And then for the other line, asymptotes, it will be 0, 4, 4, negative 4, 0. So okay, and together with my points, 3, 0, and then negative 5, 0, and then 7.5, 0, 0, 7.5. Now I will draw the graph. This is supposed to be my original graph, but then because of the modulus, we need to reflect later on. Okay, I will draw the original graph first. So now, From here, I need to reflect all the negative values. So when I reflect, firstly I have to reflect the asymptote, the oblique asymptote, y equals to x plus 4, which means now this will be reflected over here. Okay, so now this dotted red color line, the red dotted line will be reflected. So means that I have to draw, it is a curve. So it is not a straight line, it should be a curve. But it approaches the reflected asymptote. Okay. Okay, so now for this graph, we also have to reflect it in the x-axis, which means it will be somewhere, it will be something like this. Alright, so this red color will be my modulus graph. Okay, so now C or E, find the set of values of x for which this modulus is less than 15. So now when you compare with the previous modulus, the coefficients for the numerators are 1, 2, minus 15. But then here becomes 2, 4, minus 30. It means that it's double of the previous. So it means that now I can just write down this inequality I can factorize a 2 from the numerator. Okay, then these 2 can be taken out and moved to the right side. Means that it is modulus x squared plus 2x minus 15 over x minus 2, then less than 15 over 2. Now, this graph, the modulus graph already drawn in the previous part, and then I just need to add on the line y equals to 15 over 2. So just now we know that the intersection with the axis is 0, 15 over 2, which means here is 15 over 2. Alright, then let's say this is our 6. So I just need to add one more line using dotted line. This is my y equals to 15 over 2. So I need to extend my graph here. This graph just extend. Okay. So obviously from the graph, to get this inequality less than 15/2, my answer will be, okay, here between these 2 points, because the graph is below the purple line, and same for these points, which means now I need to find 4 intersection points. For your information, okay, this is the original graph. Y equals to x squared plus 2x minus 15 over x minus 2. This is the reflected graph. So when reflected graph, we need to times a negative for the original graph. Okay, and this is a reflected graph. So it is a negative. And here is the original graph. Means I will get 2 intersection points for original graph and 2 points for the reflected graph. Okay, so now to solve this question, I need to solve it separately. So x squared plus 2x minus 15 over x minus 2 equals to 15/2. And another one is going to be negative. So to solve this, cross multiply. 2 bracket x squared plus 2x minus 15 equals to 15 brackets x minus 2. Do expansion, you will get these 3 terms on the left side, and right side will be 15x minus 30. So I rearrange to get a quadratic. This 15x move to the other side because negative 11x. 30, negative 30 will be cancelled off from both sides. Factorize the x, it will be 2x minus 11 together with the x outside, which means now I will get my x equals to 0, or 2x minus 11 equals to 0, means that x equals to 11/2. So when it is positive graph, I get 0 and 11/2, which means now I will label positive, means that this is 11/2. Okay, and 0. Then now I need to find another 2 points. So when negative, x squared plus 2x minus 15 over x minus 2 equals to 15/2. Then again, cross multiply. Negative 2 bracket x squared plus 2x minus 15 equals to 15 brackets x minus 2. You will get negative 2x squared minus 4x plus 30 equals to 15x minus 30. So now when I move all the terms to the right side, because I want to get positive x squared, then you will get 2x squared. Now this minus 4x move to the right side becomes plus 4x. So plus 4x plus 15x becomes plus 19x. Then the 30 move to the right side becomes negative 30. So it will be negative 60. Then from here, I can factorize it into 2 linear factors, 2x minus 5 and x plus 12 equals to 0. That means 2x minus 5 equals to 0, or x plus 12 equals to 0, means that your x equals to 5/2 or x equals to negative 12. So now I will label this as minus 12. Okay, and then another one, this is 5/2. So obviously my answer will be between negative 12 and 0. Another one is 5/2 and 11/2. Right? So my final answer, negative 12 and 0. Another one is 5/2 and 11/2. So that's the interval for this modulus inequality. Okay, now 7. The plane pi 1 has equation. This is the equation, parametric equation. Obtain an equation of pi 1 in Cartesian form. So first of all, I need to get the n. Okay, because before you get the Cartesian equation, we need to get the vector equation. So this n is basically parallel to these 2 vectors. To get the parallel vectors, we need to use cross product. So the first vector will be 1i, negative 1j plus 1k. So I will write 1 minus 1, 1, cross. The second one is 1i, 1j minus 1k. So 1, 1 minus 1. So when you cross this, when you solve this cross product, it's basically you fix the first row, then the remaining you just use cross multiplication. Then it will be plus sign. So minus 1 times minus 1, minus 1 times 1. Okay, second, the sign is minus. Now you cover the second row. So when you cover the second row and consider the rest, then you will get 1 times minus 1, then minus 1 times 1. Lastly, you cover the last row. So when you cover the last row and then cross multiply, so I will get 1 times 1 minus 1 times minus 1. Then here is going to be 1 minus 1 is 0. So 0. Then minus 1 times minus 1 is minus 1. Another minus 1 is minus 2. Then you times with minus. This is positive 2. And lastly, you will get 2. Okay. So since your n is parallel to this vector, that means my n can be 0, 1, 1. So the pi 1, the vector equation r dot n is a dot n. Then I replace the r by x, y, z. So the n will be 0, 1, 1. So now my a, I will just take this point. The coordinates will be 0, minus 4, 3. Dots with 0, 1, 1. Then from here, when you do the cross, the scalar products means that you just multiply. Okay, just multiply. After that, you add together. So the first term will be 0. The second term is y. Third term is z. Then here will be 0 plus minus 4 times 1 plus 3 times 1. That means y plus z is negative 1. This is our, okay, let me check my point. Okay, here, I found a mistake here. The coordinates will be minus 0, minus 4, minus 3. Here is minus. So there is a minus. Therefore, my right hand side of the equation should be minus 7. Okay. Now B, the plane pi 2 has equation. This is a pi 2. Find the vector equation of the line of intersection of pi 1 pi 2. Let's say, for example, this is pi 1. This is pi 2. They will be intersecting at this line. Okay, this line will have direction vector B. Pi 1 will have the n1. This is your n2. This is your n1. They will be both perpendicular to B. Which means now my B is, I would say, B is parallel to n1 cross n2. Alright, so my n1 cross n2, just now the n1 already found, you get 0, 1, 1. Cross n2 is minus 5, 3, 5. Then again, using the same method, I will get plus, cover the first row, then you will get 5 times 1 minus 3 times 1 minus 0 times 5 minus 1 times negative 5. Then plus, cover the last row, 0 times 3 minus 1 times negative 5. So from here, you will get 2 minus 5, 5. Okay, so means that my B is going to be 2 minus 5, 5, because it is parallel. So now I need a point, okay, from the line of intersection. So the point can be solved by solving the pi 1 and pi 2 equations. But then I will solve the Cartesian equations. So it means that the first Cartesian equation, y plus z equals to minus 7. So the pi 2, right? This is a pi 2. It's very simple. Just times the x to all the coefficients here. X for I coefficient, j for times by y, then the k by z. So I will get minus 5x plus 3y plus 5z equals to 4. This is my second equation. So to find the point of intersections, I can, now from here you can see 2 equations but 3 unknowns. It means that we will be getting infinite solution. So I can let my z be 0. You can let the y be 0 any values, right? So then from the first equation, my y is going to be minus 7. Then from second equation, so I will get minus 5x plus 3 brackets minus 7. Then plus 5 bracket 0 equals to 4. Means that 5x, I move it to the right side. Then this one I move here. So minus 21 minus 4. That means it will be minus 25. Then my x will be minus 5. So means that now I get the point. Okay, therefore the equation of the intersections of pi 1 and pi 2. It will be r equals to the point with coordinates minus 5 for the x. Then the y is minus 7. The z is 0. You can let it be any other points plus t of this direction vector. 2 minus 5, 5. Okay, so that's the solution of this question. Otherwise, you can just solve these two simultaneous equations directly. And you'll be getting the same answer as well. Now, the line L passes through a point A with position vector this and parallel to another vector, where A and B are positive constants. Given that the perpendicular distance from A to pi 1 is square root 2, find the value of A. So now, for the pi 1, let's say this is a pi 1. Okay, the A is on the line L. Now, you need to find, is given that the perpendicular distance is square root 2. So from here, perpendicular distance from point A to pi 1 is square root 2. So I will say that square root 2 is r dot n hat minus a dot n hat. This is the n1. So now from the previous part, r dot n hat is basically, this is your r dot n minus 7, right? Therefore, the n hat is basically the value minus 7 divided by the magnitude of the n. Which means, okay, so from here I will say pi 1 is r dot 011 equals to negative 7. So then here it will be negative 7 because this is basically r dot n equals to a dot n. This is already a dot n, right? So over magnitude of the n. So magnitude of n is 0 square plus 1 square plus 1 square. Minus the a dot n is the a coordinate, which means a minus 7 dot the n is 0, 1, 1 over the square root. And this is square root 2. So from here I will get square root 2 equals to, now the perpendicular distance cannot be negative. So I put a modular sign to make sure it is positive. So here I will get minus 7 minus, this one you do expansion. First is 0 plus a times 1, then plus a minus 7 times 1 over square root 2, okay, modulus. So now the square root 2 can be moved up, becomes 2 equals to modulus negative 7. This is 0. So I will get negative a, and then this is going to be negative a plus 7. So from here, the minus 7 and plus 7 will be cancelled off. I get 2 equals to modulus of negative 2a. So after the modulus, it will be 2a equals to 2. Hence, the a is 1. Okay, now D. Given that the obtuse angle between L and pi 1 is 3 over 4 pi, find the exact value of B. Okay, so now, let's say for example, this is the diagram. This is the pi, and here is the L. The angle, obtuse angle between L and pi is, this is pi 1, is 3 over 4 pi, means that this is 3 over 4 pi. So if here is 3 over 4 pi, which means this is 1 over 4 pi. Okay, the acute angle. And then from the pi 1, we have the n1, which is always perpendicular to the pi. And then the L has direction vector B. Okay, so now I can find the angle over here. Right? So now for your information, the total of these two angles is half pi, which means my alpha here is going to be half pi minus 1 over 4 pi. Alright, so alpha is half pi minus 1 over 4 pi, which is 1 over 4 pi. I will define, let alpha be the angle between B and N1. Okay, so now B dot N1 equals to magnitude B, magnitude N1, cos alpha. So the B is given in the previous question. B is this, because the line is parallel to the vector. This is the direction vector of the line. I will get 1 minus B, B, B. So here, 1 minus B, 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 dot, my N1, from the previous question, my N1, this is pi 1, that means this is my N1. It will be 0, 1, 1. So here, 0, 1, 1 equals to magnitude of the B, so 1 minus B squared plus B squared plus B squared, then square root of 0 squared plus 1 squared plus 1 squared, cos alpha is pi over 4. Right? So from here, I need to simplify. Again, for the vector, for the scalar product, you multiply and then you plus all together. So the first one is 0, the second one is B, the third one is also B. And then now for this square root, the first square root, I need to do expansion. Square of 1 minus B, use the formula A minus B squared equals to A squared minus 2AB plus B squared. I will get 1 minus 2AB plus B squared. Then plus with this 2B squared, it will be 2B squared. Square root 0 squared plus 1 squared plus 1 squared, it will be 2. Now cos pi over 4 is basically 1 over square root 2. So from here, I can factorize, I can cancel off square root 2 and 1 over square root 2. Okay, so I can cancel off these two terms. Then now my left hand side is 2b, right hand side is square root of b square. Here is b square, here is 2b square, becomes 3b square. So I'm getting 3b square minus 2b. Okay, this is not 2ab, mistake. 2b, because your a is 1. Right, 1 minus b squared is 1 minus 2b plus b squared. So here is going to be minus 2b plus 1. So to simplify this, we need to square both sides. So when square both sides, left hand side becomes 4b squared. Right hand side, the square and square root cancel off. then I will get 3b squared minus 2b plus 1. So I move all the terms to the left hand side in order to get positive b squared. Then I will get 1b squared plus 2b minus 1 equals to 0. Okay. Then now the question says find the exact value of b. So you will notice that this quadratic cannot be factorized completely. Therefore, I need to use the quadratic formula. Quadratic formula is basically ax squared plus bx plus c equals to 0. Then the x is going to be minus b plus minus square root b squared minus 4ac over 2a. But then now I will not write down a, b, c because I already have the b over here. Okay, so then I will just direct write, substitute into this formula. So now my x becomes b in the equation. So I will write b equals to minus b. My b is basically the coefficient of b, which is the 2. So minus 2 plus minus square root 2 squared minus 4. The coefficient for b squared is 1 here, multiply with the constant, which is minus 1. Then over 2a. The a is the coefficient for b squared, which is 1. That means here I will be getting minus 2 plus minus 2 square root 2, right? Because 2 square minus minus 4 is 8. 8 is 2 square root 2. Then over 2. And then I will get minus 1 plus minus square root 2. So now we cannot accept b two values because it's mentioned one value. So how to choose the value here? Alright. So look at the definition of the b first. B, A and B are positive constants. So when you consider the negative over here, when you consider this negative, right, the first term is already minus 1. Then if you minus the square root 2 again, it will be more negative. So you just write here, since B is positive constant, therefore the B is going to be minus 1 plus square root 2. Okay, so we have come to the end of the video. Thanks for watching. Please subscribe to my YouTube channel if you enjoy watching my video. Thank you. Bye.